You can continue with eating as well, but finish after first slide, please. It's not good to eat. Šalim se, ma svi razumiju ovo što ćemo reći. Our next presenter will be Mr. Giorgio Sola, who is in this moment has been scanning, in the process of scanning. So, we are missing Giorgio Sola actually. Please bring Giorgio Sola from the 3D scanner. Okay. Già arrivato. Okay, Mr. Giorgio Sola, coming from Rome, we are happy to hear his presentation. And after that we have one last presentation, very interesting, because to conclude all these topics we have been speaking about whole this day. Some possibilities of European funds, some possibilities of future cooperation. We are here in agency of Rijeka Regional Development Agency, and we'll see maybe after on the round table, is there some opportunity to continue or to make some new ideas for future projects. Mr. Sola, here's your mic.
Thank you, Sven. Thank you for inviting me. I'm Giorgio Sola, I'm coming from Rome, I'm a professional. I have a collaboration with the Universidad de Cantabria in Spain, but I'm here, thank you. I'm here because I have to speak about a very rare, a very particular argument. So, the real production of art. I have to say we are talking about metal art, so bronze and metal, I don't know, aluminum or something like that. I'm not an artist, of course, but normally Italian artists comes to me because they have to produce their piece of art. So, we have to start talking about what the artists want. How can I build this piece of art? What is the process? Because sometimes, every time artist brings to me some piece of paper with a draft, handmade. Rarely they bring to me some sample ceramics or something like that. But they doesn't have the skill to produce the real piece of art because of dimensions, because of technology, because of, I don't know, because the spirit of the artist is inside, is not outside. One thing I have to do right now that art, a mechanical piece of art is something emotional. Maybe this could be less complex than a mechanical part of a mechanism, for instance. But the relationship between the artist and the piece is very strength. So it's very important to enlace a relationship between us, my company, for instance, and the artist. So the artist has the idea, the draft drawing, a little sample, but the artisan companies really create the final artwork. A brief presentation, the company who produces this one piece of art, because we are not talking about production. We're not talking about I have to produce 1,000 pieces of this statue, but one statue, two statues, or something like that. This company is an Italian manufacturing company that is in the market since 1963. He works in metal. Just one slide to understand the core business of the company. This company produces mechanics parts, so metal working structures, mechanics to the electronics, mechanics due to arts, stairway, also mechanics for assistive technology, windows and facades, and art. What is the process of the production of art? So we understand that this is a unique design process for every piece. So we have not the possibility to standardize the process. So, first of all, the artist brings his idea or prototype Of course, we are a commercial company. This is not an institution, so we have to adapt the idea to our technology. We have to earn. So we engineer the prototype, the idea. I don't know how, because every time changes. Maybe we have to use just a blackboard. Maybe we have to use just a drawing or a CAD or a 3D model or nothing. We are going to see an example where we didn't design anything. So using these schemes that comes from a blackboard, I'm not joking. We have a blackboard because sometimes the artist draw on this blackboard and says, I want to reproduce this drawing here. The administrator of the company says, where the pencil goes, the metal can go. So using these schemes, our workers creates the piece of art. The artist brings his idea or prototype. This is an angel. And here the artist brings us some Reno CAD files. We've got problem with that after we are talking about this. So we started to have some choosing. The professor said before, what is the shape we need to give to the piece of art? What material do we need to use? Because of course, you know, there's the different technologies to use an iron metal or not iron metal. It's different. We adapt the idea of our technology. This is a tricky cut it by hand plasma and then punched, and this is curtain iron. What is the technology we need? We have to choose that. How can we adapt the building process on our technology? What do we need to involve subcontractors? Do we need to involve subcontractors? Because of course we have two big companies, but the technology or the world we can use, we haven't it. We engineer the idea. I say blackboard software like that. This, for instance, is a piece of IEC 316 stainless steel metal. This is cutted with a process of a chemical cutting. So we produce a mask. We throw some acid that cut the shape, and the same acid can engrave this part. This is the problem. What is the best way to explain our workers what to do? Because there are some pieces that are truly mechanic, so we can use a CAM system. This is simple. A 3D model, a CAD model, a CAM model, and stuff. Sometimes the work is really handmade. How can we transfer the intention of the artist to the workers to produce this piece of art? This is a big problem. So we have to use a very skilled worker. Manual drawings, for instance, CAD drawings, solid modeling. And so what software can be most adequate to follow this work? So using the scheme, the workers produces the piece of art. This is another shape of curtain. This is in Riyadh, in the Middle East, and this is cut by water, a water jet. Working on a piece of art is not like working a mechanical piece. At the end of the work, we could imagine that this is the same thing, but it's not, because of the emotional. Of course, the workers need to have a great imagination. And sometimes artists and the engineer have to be over the time of production and at the side of the workers to help him to interpret the fantasy, the idea of the artist. So, the unique design process for every piece is truly, we are a commercial company. We're not a university or something like that, so we have to deal with the time to produce. The time to produce is the time between the starting of drawing and the starting of manual or machinery working. And the time to market. The time to market is the time that lies between the starting moment of machinery or hardware made to the time when the piece goes out from our factory. It means that sometimes not possible to choose the best designing technology or the best productive technology to produce one piece of art, because if we have to produce 1,000 pieces, we can imagine to looking for the best process to reduce some times, but we haven't this time. Normally we have some weeks to finish the work, but at the end we can say that's not possible to optimize the process because of one piece. So the process in this case is artisanal. It means that the process is artisanal, the idea is artisanal, but the way of working is not artisanal. So let's see some work. I'm going to say what is the artist and some other information about the work. What is this? This is the mosaic in Arapacis in Rome. When we will come to Rome, you'll surely visit the Arapacis. This is a very ancient area of Roman time, and this is close by the Tiber River. The artist is Mimmo Palladino. This is a 3D 49 square meter mosaic that Arapacis, Rome. So this is an apartment, 49 square meter. It's vertical. We had to do a 3D modeling with a mechanical desktop. This is Autodesk software for the planes. We're going to understand in a few minutes. A 3D seismic modeling with a multi-frame. This is Australian software for the carpentry seismic structure behind this mosaic, because 49 meters, it's a lot. So another problem had to be, we produce it in the roof, in the horizontal, and we have to move it like this to the vertical. The movement could lead some elasticity of the structure, and you have to imagine that the structure is stainless steel, iron, aluminum, but also ceramic. So this was a very critical part. Classical tube welding construction, two-dimension milling, big size machine, 342. The mosaics had been passed. Yeah, this is not in English. The mosaic have deployed to an aeronautic honeycomb sandwich panel, and the installation has been a really critical process due to the elasticity of the structure. So this has been the infrastructures. You see, it's a classical, more or less, classical tubing, welding, carpentry from the top. These are the panels. Here we can see the 3 dimensions of the structures. And this is an honeycomb sandwich aluminum structures. You can see them in the airplanes. Look at the complexity. For instance, these plates, we had to put this place just for the movement, not more. The vertical positions, and my workers that were very happy to do that. This is a nude stainless steel easy 304 nude. It has been built for the anniversary of Italian Republic, and this is a nautical band. It's all welded and with a thick welder. 2 inches diameter stainless steel tube for Italian Parliament room. The model was a real nautical rope, so we hadn't to design that. Imagine the difference between the first example and the second one. The first example we planned we have to design lots of things, seismic, 3D modeling, and in this situation we did nothing. So the worker, no project, the worker that just worked mirroring the sample using a 90 degrees precurved commercial tube or bending through the bender machine linear commercial tube. This could be considered the most important work in art we produced. This is the question statue of Marco Aurelio in Rome. When you will come to Rome, you will go to Campidoglio. Campidoglio is where is the measure of the city. Just in front of that, there is the statue. The statue we are going to see is this one, the copy we made, because of the original is inside a museum. How do we produce this? Something like Alessio said before, more or less. So a 3D scanner, a NURB modeling, and something like that. The difference is, now we have the technology. When we produce it, we invented the technology. We don't know who's the artist, but I had the possibility to see some Michelangelo and Caravaggio sample of that. The construction of the original was very lots of time ago. We reproduced it until 1997. It's a very huge statue, 4 meters for 4 meters for 2.3 meters. This is the alloy of the bronze. How do we produce it? We built up a 3D laser scanning with an artisanal structure who hang 2 pointer lasers like that. We carry out lots of points. We generate 2 groups of NURBs, one for the Marco Aurelio and one for the horse. And then this NURB has been divided into slices. 5 millimeters of slices. The material of these slices was PVC, polyvinyl butyrate, and we milled every slice with a large size 2-3 axis milling. When we produced the NURB, the important thing we had to do was to increase the volume of these NURBs because we was thinking about the reduction of the volume of the bronze and the time he get lost the head. Then it has been welded. Then we produced the white horse, PVC horse. We use that to have the investment casting processing, and then, well, we're gonna see photos is better than me. This is the NURB. This is a part of the horse. We can see all the slices, the mounting, and the horse. Imagine that this is not, of course, the final statue, but it was really beautiful. The mayor of the city wanted to use the statue in the place of the original for 2 months. It was incredible. They call it Phantom Horse or something like that. We can see here, for instance, the slices. One particular, these slices, we can see the slices from something close, from a point close to the statue. If we put very length from the statue, we don't see the slices. We see perfectly wings, all the defection of the original statue because of a particularity of a human eye that interpretate the information between the resolution it cannot see. So our eyes not normally doesn't see things in slices. Normally they see things in natural. So from the length, he invented the part between two slices, and the statue, and from the length was perfect. And then look at the slices here. And then this has been the process when this girl put some plastiline between one and the other slices. This is the part of the construction of the port for investment casting, and then they uses they call the bronze, and so this is a part of the cleaning of the bronze and the reconstruction of the statue. Of course, it has been done into, I remember 13 pieces, welded, remounted, smoothed, and then painted. The copy at that time and the copy right now. This is a tabernacle. This is a new. The artist is the architect Marco Pedreschi, is very famous. It has been a 3D vertical structural glass punctual fixing, 3D modeling for the curtain, a laser cutting for curtain, and then rolled, 3D cutter for the brass, manual modeling for the upper part when investment casting, then investment casting, brass and gold. I like this example because here we can see the connection of very different mechanical techniques. Laser cutting, bending, 3D modeling, manual modeling, investment casting, golding. For instance, this is a very manual. I think 2,000 years ago they already produced like this. Welding. This is milled with normal. This is my machinery, normal milling machine. This is wood, and then, and the final, it has been a quenched glass, extra clear. The final. Cotton shapes. This is a Denmark artist. These things are in Casina Vladimir room. Is very. I don't know what the meaning, but they are shaped in cotton. Very simple. A 2D cut design. Laser cutting for the cotton. Aging and waxing for the cotton. So we can see just this shape already aged. It's simple. Let's talk about something different. For instance, look at this. This is a table, one piece of table, 6 meters long, and this is built with different techniques joined together. For instance, we designed this shape, this shape, this shape, other shapes on the upside, and this shape, and we cutted it with a laser, of course, and then all these pieces of metal have been bended manually because it's simple to generate it with the 3D software, for instance, Rhino, something like that. But the transformation from that to a regular piece is very difficult. So when I have to produce something little, no problem now with milling machines or 3D printing. But these huge dimensions of things, we have to join different techniques manually and machinery. We already see this. This is an angel. This is on focus, but I want to show you this because, you know, we say that all is compatible. That's not true. This has been modeled with Rhino 3D. The artist gave me the Rhino design. I transformed it into a two-dimensional drawing, but the radius of the lines changed. So the prototype was failed. We had to interpret the CAD system. Another time we had a really bad problem with the connection between CAD and CAM system, because Van asked me to talk about the CAD and CAM, no? You know what is CAM? So it was very simple because we had to produce a shape like this. Half of a circle. We design half of a circle with a line crossed. When we produce it with a milling machine and we measure that, that was not in shape. Nobody could understand why. They said, okay, this is a problem between the connection between CAM and CAM, CAD and CAM. We intended that the CAD they uses to generate the shape was using the Bezier curves and not the geometry of AutoCAD. And you know that when you use the Bezier curves, the connection between one straight line and one curved line, he doesn't interpret it as a cuspid. He interprets it like a curve. So automatically the CAM system changed the shape between a cuspid here to a curve. We hadn't the possibility to mill the shape. So how did we resolve the problem? Very manually. We engraved, so we milled a circle, not more, and we milled a straight line, not more. Directly we had to shape it. So we have to care to take a particular attention between the connection between CAD system, 3D CAD system, and CAM system. And other things we have to focus on. The point you have to use to mill, to lathe the piece has to be thought and compatible with the software you're using to the CAM. Because, for instance, you can mill around a shape, but if the workers put in different hardware with a different diameter you thought, it's wrong. I know this is something like a university situation, and these arguments are a little rare, but they are important. So how do we produce it? This is done with a lathe, of course, and then we cut orthogonally with a water jet machine. This is the most horrible piece of art we produce. I don't understand the meaning. What is this? We can see it. Look at that. It's enormous. Look at that. The artist is a man who is a little crazy because we punched him saying this is not correct, this is a shape that doesn't work, and he was present from the beginning to the end. Curtain, handmade, they are slabs bended manually, then welded, then aging and waxing. He put it into the center of Rome. He fell down. He fell down, and he took from the police an advice because of intended criminal or something like that to kill something. No, it's not a joke. It's true, because of the distribution of heavy is evidently wrong. But we had the possibility to do this, and he brought to us a sample, a ceramic 3D ceramic sample, very little, and we had to build up this. I want to show you this photo because it's the moment when they bring away from our factory this, because it has been a very beautiful day, because that shape brings us something negative, you know. So what are the instruments you use? Designing a 2 CAD system. It's a docile system, graphite, SolidWorks, and Inventor, and Multiframe. Our factory has a laser cutting Masa 2 kilowatts, a water jet cutting machine, 3D plating routing big size, normal manual plasma cutting. Manual plasma cutting is a torch manually a worker can use. Of course, this kind of torch is at the first place when we work in art, because you know, and normal machineries of a carpentry company. The important thing, this is marketing. We put artistic spark in all things we produce. Thank you.
Thank you very much.